This is section 8.4, simplifying rational expressions. This is part 3, which is how to divide rational expressions. Now, you're going to notice when I go through this, dividing rational expressions is the same thing as part 2 outside of one step. Okay? And that's the first step. And the first step says we're going to take the reciprocal of the second fraction and multiply, or the 1 after the division symbol. Okay? Otherwise, you'll notice these other steps here are exactly the same as multiplication. Okay? So let's take a look at the examples. Again, first step says I'm going to take the reciprocal of the second fraction. So in this case, I've got a 2 minus x and an x squared plus 2x plus 1. That's not going to change. And I'm going to change the second fraction and I'm going to multiply. So I'm going to flip it. The bottom becomes the top becomes the bottom. And now we're just going to do it like we did multiplication. So the next step is to factor. Now, one thing you notice is a little bit different about this problem is if you look at the top left here, you notice these are kind of flip-flopped. And a lot of times, guys, when they're flip-flopped where x is negative, what they want you to do is take out a negative 1 to make it look like normal. So if I take out a negative 1, the x becomes positive and now the 2 becomes negative. And now it looks back normal. Factors of 1 that add to 2 are x plus 1 and x plus 1. And x squared minus 1 factors out to x plus 1 and x minus 1. And on the bottom, factors of negative 10 that add to 3 are positive 5 and negative 2. Okay, now once I've done that, again, once I've factored, I got to state my domain. In this case, my domain, x cannot be. For here and here, it's the exact same. It's going to be negative 1. For here, it's going to be negative 5. And for here, it's going to be positive 2. Any one of those three values will make the denominator 0. And we can't have 0 in the denominator. Okay, so once I've calculated my domain, next step here is going to be to cancel out anything that's the same on the top and the bottom. So I've got an x minus 2 here and an x minus 2. One's on top, one's on bottom. I've got an x plus 1 and an x plus 1. Other than that, everything else is different, so I can't cancel anything else out. So now I'm going to put it all together. I've got a negative 1 times an x minus 1. On the top and on the bottom, I've got an x plus 1 and an x plus 5. And that completes your problem. Now you'll notice again, it's very similar to multiplication outside of the very first step. Okay, so let's take a look now at problem number 6. Okay, so first step on problem number 6 is I'm going to flip the second fraction. So x squared plus 5x plus 4 over x squared minus x minus 12. That's going to stay the same. I'm going to multiply, but I'm going to flip that second fraction. Okay. Now, once I flip that second fraction, I'm going to multiply. So the next step I've got to do is I've got to factor everything out. Factors of 4 that add to 5 are x plus 4, x plus 1. Factors of negative 12 that add to negative 1 are x minus 4 and x plus 3. Take out a 2x on the top right. I'm left with an x minus 3. And on the bottom factors out to x plus 1 and x minus 1. Once I've done that, I'm going to state the domain. X cannot be 4, negative 3, negative 1, and positive 1. For right here, it's positive 4. For right here, it's negative 3. For right here, it's negative 1. And for right here, it's positive 1. Any one of those four values will make the denominator to be 0. And once I'm done with that, now I can cancel out things that are the same. And you'll notice there's not a lot that's the same. The only things that are the same are the x plus 1 and the x plus 1. So now I'm going to combine everything together. So I've got a 2x. Now, it doesn't matter what order you put them in. Ideally, if you have a monomial, you want to put that first. So then I've got an x plus 4 and an x minus 3. Again, it doesn't matter what order you put them in terms of the binomials. And then on the bottom, I've got an x minus 4, an x plus 3, and an x minus 1. Okay? Now, if you put everything together and you notice that things are the same, then you can cross them out and then just write your final answer then. Sometimes it's a little bit easier to do that as well. Okay? All right, this concludes part 3 of section 8.4, which is division of rational expressions. Don't forget to make sure after you watch this video to complete your WSQs.